Hello, my name is Sergio Salcido, and this is my Dinner Plates project within Visual Studios. So what we have here is we have a simple C program, and within this we have a main function of buffet plates. Next, we have some assembly code, and what this is showing is it's showing that we have the assembly procedure in between buffet plates proc and buffet plates end. And then what we're doing here is the commands move is adding an integer to each one of the registries EAX, EBX, ECX, and EDX. Then we have the push commands, which are adding the registers to the call stack, and then the pop commands, which is popping those registers out of the call stack. And then lastly, I just have a header here declaring the buffet plates for the compiler. Alrighty, and so let's go ahead and walk through this through the debugger so we can see exactly what's going on and ways to prove that it is working correctly. So first things first, I did add a breakpoint to the buffet plates within my C programming. So that way, as soon as we start debugging and then we step into the program, we'll go right into our assembly code. Alrighty, so first things first, we see here that the registers, they don't have anything, any current integers in there for EAX, EBX, ECX, and EDX. Alrighty, so when we go ahead and execute the move commands, it'll go ahead and move those into those registers. And we see that here, EAX1, EBX2, ECX3, EDX4. So with that, the next commands we have here is a push, which is pushing those registers into our call stack. And so we can see that within the memory itself. Now, ESP, when I'm typing in here, this is just taking me to the top of the call stack. Currently in the top of the call stack, we don't have any of our integers. Now let's go ahead and walk through the commands of push, and we will see that now we have EAX, or the integer 1, in the call stack. Let's continue on. Now 2 is in there. Now 3 is in there. And lastly, now 4 is in the call stack. Alrighty, so now that they are all in the call stack, this pop command is going to pop them out of the call stack. Now, when that does occur and that command happens, it is a last in, first out scenario. So EAX, EBX, ECX, and EDX are going to, the last one is going to pop out first. So that's EDX, and it's going to follow in a reverse order all the way to EAX. So what we're going to see there is EDX is going to be the first one out. ECX is going to be the second one out. EBX is going to be the third one out, and EX is going to be the fourth one out. Now we can see that in two ways. So we can see it in the registers itself, which is going to list that order with it popping out of the call stack, and then we can also see it in the memory where that integer is going to be popping out of the call stack itself. And I'll show you both ways. So let's go ahead and execute the first pop, which is EAX, and it's turning into 4, meaning it's the last one to pop out of the call stack. Now, if we go to the call stack itself, we previously had that fourth integer in our call stack, but when we go to the top of the call stack now, it is the first one out. So now we only have 3, 2, 1. And then if we go ahead and execute again, we'll see that number 3, or ECX, is now popped. And so now we only have 2, 1. And it's the third register. Alrighty, and let's continue through. So then we see 2 pop out. And lastly, now they have all been popped and they are no longer in our call stack. And then the registries just indicate that order that the pops occurred. And that is that assembly code and how we moved an integer into a registry. We pushed it into a call stack and then popped it out of the call stack. And then the assembly code here, the buffet plates proc and buffet plates NP, that is just the assembly procedure itself and is ending that code for the assembly. And then this RET is a return that takes us back to our C program. Alrighty, and that is everything for my presentation on move, push, and pop. Thank you for your time.